We are continuing the tutorial on variation. The last episode we did the introduction and also direct variation. In this episode, we'll be treating the inverse variation, the inverse of a number, the variations that we can get from that. So in this case, the inverse variation, in the case of inverse variation, the first quantity varies inversely. We know inverse of a number is the change or reciprocation of the number as per another quantity. So the statement y varies inversely as x simply put or simply means that when x increases, the y will decrease by the same factor. So as x is increasing, y will be decreasing, or vice versa. Meaning, if x is also decreasing, the value of x will keep increasing. And how do we represent that? Yesterday we mentioned that this sign shows the variation constant. So in this case, if y varies as inverse, we know if it varies directly as x, it will be x. And we know x has a denominator of 1. So the inverse of that is to reciprocate. Let your 1 as your denominator become a numerator. So if we are changing this as a constant of variation to become k, then it will be y equals to k times 1 over x, where the k will multiply the 1 to give us this. So in this case, if you want to find the constant, you only have to multiply the two variables. Both the independent and the dependent variable will be multiplied to get the constant. All right. Now, what are some of the real life situations we can get under inverse variation, where one quantity is increasing, the other is decreasing? I'm sure if you are traveling from a loading station to your destination, it's going to involve a distance and also involve time spent, taking into account the speed. So if you are going to hold the speed as a constant term, we are going to travel on the journey on a constant speed. The speed will not change. If it is 40 kilometers per hour, it is from the beginning of the journey to the end. It's like when you start your journey, you are going to have your distance completely being, let's say, 40 kilometers in front of you. Then the time is going to be 0. So as you start the journey, the 40 kilometers will be decreasing as you are getting to your destination. Then the time will keep increasing from 1 second, 1 hour. When you get to 5 hours, where your destination is, then the distance now become what? 0. So as the distance is decreasing, your time is increasing. That's an example of what? Inverse variation. Also, when you consider a workplace whereby we have a job to do, then we are increasing the number of employees when the work is the same. As we are increasing the number of employees, the time spent in working or the time spent in accomplishing the task becoming what? Smaller. So if we were to be 10 working within 5 hours, when the number is increasing to 15, it means the hours you spend will also what? Decrease. It's a fair example of what? Inverse variation. We yesterday introduced a graph, how we can also represent the direct. Let's see how we can represent the indirect or the inverse variation. On our x-axis, we have y-axis. So let's label 1, 2, 3, 4. 1, 2, 3, 4, 5. Equal interval. So if you are taking the relation to be y equals to, let's say, 2. The 2 is the constant here. So we are going to be using this. We know in this case, your x can never be 0. So we are not going to have the origin. So now if x is 1, it means 2 over 1. That will be give us to what? 2. So the point will be here. When x becomes 2, 2 divided by 2 will be what? 1. So 2, you get 1 here. Let's just say if x is 3, we are going to get the values of y to be 0 point, meaning it will decrease below the 1. So we can see that as the values of x is increasing, that of y is also what? Decreasing. So in this case, our curve is going to look something like this. So that is for inverse variation. And don't forget that x can also assume a negative values. If the x assume negative values, then our curve is going to move in this direction. So this is a representation of inverse variation. Let's take a question and see how we can do that. If y varies inversely as what? X. We know we are going to have y varying inversely at x, translated as y equals to k over x. So when your y is 10, x is what? 6. So we are going to introduce that. You know, from here we can also find the k as xy, meaning in place of x I'll be having 6. In place of y I'll be having what? 10. That gives us 60. Let's do our substitution to mean y equals to 60 divided by what? X. That is if we substitute the value of k into, this is our first equation. Now, then what is y when your x is now 15? So whatever you do, you only substitute the value of x into this second equation. So x is 15, meaning the value of y is going to be what? 4. You can see from here that this is 10 from the beginning. It moved to 4. It was 6 in the beginning, increased to 15. So as x is increasing, the value of y also keep what? Decreasing. Now this one is left for you. You can also try and send your answer in the comment section. Let's look at this. Given that x varies inversely as the square of what? Y. So we have x to be 64, y is 3. So now we are going to find x when y is what? 8. So you can see from here, we are going to have x varying inversely as the square of y, translated to mean x equals to k over y squared, the first equation. So now we can find what the constant will be when we multiply x by what? Y squared. Now only do substitution for your x, which is going to be 64. That of y is going to be 3. And don't forget there's a square, meaning 64 times 9. And that will give us 576. That's 576. It means the value of k is now this. So we can substitute x equals to 576 divided by y squared. So what are we looking for? Find x when your y is 8. So right away, I'll only have to have x, which is already here, so equals to 576 divided by 8, which will be squared. Then if we square this, 576 divided by 64. Don't forget 64 and 9 give us this. So if you divide it, we are going to get 9, meaning x will be equal to 9 when your y is also becoming this. Don't forget, the x in the beginning was 3, increased to 8. The x from 64 decreased to become what? 9. So that is the relation in inverse variation. I believe the concept is well explained to your understanding. If yes, try the question 2 and send your answer in the comment section. Thank you for watching. Like, share, and comment. Bye-bye.